reaction to the positivist is the person that maybe influenced more than anybody the thinking about the history of science and the nature of science. And after him, both the history of science and the philosophy of science, well, even maybe before it changed a bit, but after him there was a big change. And now there is much more consideration for social factors, social and cultural factors in looking at science. And it's very different from the recent view. So we'll see today. Was inspired and influenced by Ludwig Fleck, and we will talk in a moment about him. Unfortunately, he's someone who wasn't recognized, but he was the first one to actually talk about it almost a quarter of a century or more, actually, about 27 years ago, or 30 years ago. And some other people, I mean, from history, psychology, philosophy, and he came up with a view that challenged very, very seriously the received view. So let's talk about, because Ludwig Fleck is usually not recognized, we should give him some due respect. And it's also, he has a very, very interesting story. And part of the story why he's writing and not recognized, it could be a Hollywoodian movie. So Ludwig Fleck published a book in German in 1935, which actually anticipated, as Buch says in his preface, many of his ideas. And some people said that he actually was much more sophisticated than Buch in putting these ideas. But what happened is that he was born in Poland. He was born into a Jewish family, and he studied microbiology. He was a scientist. And when the war started, and he was actually expert on typhus and syphilis and vaccines, I mean, producing vaccines. Because during the war, he produced vaccine for syphilis, for the urine infection. And because he was Jewish, he was at some point, at the beginning, he was protected by some Polish people who argued that he was employed. He was born in Lewo, which was Poland, but became part of the Soviet Union at some point. And then the Germans sent him to Auschwitz. His wife, and he was actually a labor worker at the beginning, but then they discovered that he's an expert on microbiology, and they employed him for the study of vaccines. And then he was sent to, I think, Württemberg, which was another camp, and there also was employed. Because of his expertise, was basically, I mean, saved. And what happened is that the book that was published in 1935 got very little attention before, and because of the war, no attention whatsoever after. So he was published in German. There were some reviews. Some say that maybe 19 reviews. Only 2 of them in philosophy, and they were critical, like Polish people. And the other were in science magazines. They were well received, but didn't influence actually the history of philosophy science. After the war, he was a microbiologist. He was the head of some. He wasn't actually at the university. He was, I mean, working in hospitals and some foundations. He was pretty prominent. I mean, in Poland, and even became, I mean, a member of the Academy of Sciences. And but he didn't write many articles on philosophy articles that were published in German and Polish. And then in so that was part of the reason why it wasn't, why it wasn't recognized. And then in 1957, he immigrated to Israel. He was sick, the cancer and the heart problem. And with the promise that he will be at the Hebrew University, the Faculty of Medicine, but he couldn't speak any word of Hebrew. So he didn't get the job, but he got a job in an institute for biology, this Israeli Institute for Biology, which is also believed to be the place in which Israel produced its biological and chemical weapons. And he worked there from 1957 to 1961 when he died. At that time, he actually sent 2 articles to Britain. One of them, I think, was probably to the British Journal for Philosophy of Science, who Popper was there. And so the 2 articles were rejected. One of them actually was rejected after he died. So that's the story. One of the reasons is that he published as a scientist before the war, and the war, and the fact that he published in German, and the language, he wasn't native in German, so the language was also kind of difficult. The other reason is that his writing, in the institute, he befriended another Polish Jew who immigrated after the war, who was actually the deputy director. And he left him all his writing on the manuscripts. Now it turns out that the other person, that's an interesting story, Marcus Springer, was a top spy for the Soviet Union. And he was discovered at some point. So he came to Israel. He was also, he fought with the Soviet Union, against the Nazis. And then immigrated at some point to Sweden and then to Israel. But he was a KGB, the highest rank, some say, in Israel. And given that this institute was top secret, nowadays we don't know much about it, except that it produces, biological and chemical weapons. He became, and for many years he wasn't discovered actually. And the story related to Ludwig Fleck, you asked yourself how it's related to Ludwig Fleck. He left his writing to Marcus Klingelberg after he died, and he was caught in 1983 by the Israeli Internal Intelligence, the Shin Bet, who confiscated the papers. And since then, they are in the hands of the Israeli intelligence. I had stories from people who are friends of Marcus Klingelberg, and they said that nobody can get the papers for some reason. They're nothing about secrets. They're just secrets of history of science, maybe, or philosophy of science. But so that's another reason why the research on Ludwig Fleck and his writing, are less known, because we don't know actually what he did. Or at least part of what he did and how important the manuscript that he has. Hopefully, at some point, there will be a spy in the Israeli intelligence. That would be interested in history and philosophy of science, and maybe we will release it. But at the moment, it's not there. Interestingly, I'm also connected to that because I was playing basketball when I was a kid, and one day my coach disappeared. And it turns out that he was a spy for Syria. And it was so secret that they didn't even say. Also Klingelberg, when he was caught, he was kind of a prisoner X. He wasn't known by his name, and even the people in the prison didn't know who he was. So it was all top secret, and he was he got like 17 years. In jail, my basketball trainer, and it was for ideological reasons. He spied for Syria because he was very communist. But it turns out that the daughter of Marcus Klingelberg actually was married to this basketball trainer. So it's kind of all this incredible story. she married him when he was in jail. She was also very left-wing, very Marxist, I mean, in her ideology. So that's the story. Marcus Greenberg actually lives still, he's 95 maybe or 6 in Paris. He cannot talk about, I mean, he actually signed, I mean, that he won't talk about anything that he did. So he actually is very difficult to get, except this information about the writing that I had from a postdoc in Germany, who's coming actually to Europe, be a postdoc for 2 years, and she's trying to publish, I mean, the writings of Ludwig Flegg, and also to have a new translation. So the story is that he hasn't influenced. He's considered nowadays Ludwig Flegg as someone who anticipated, I mean, an influence maybe Kuhn, but it's more kind of, people don't study so much, I mean, his book. Although in Europe, especially in Germany and France, he's highly regarded, and some people think that his writings are much more sophisticated than Kuhn. They're more difficult to read though, so I don't think you are really. Kuhn is difficult, and it's even more. But anyway, he anticipated a lot of the ideas that Kuhn had about 30 years ago. And that's the story. Okay. Going to Kuhn, let's see, I mean, how Kuhn saw the history of science and the nature of science. And remember, we talked about the received view. So what we will try to see now, how actually Kuhn, how Kuhn's view is different from the received view, that would be helpful, I mean, in understanding this view. So if you remember, the Popper said that his criteria for the distinction between science and non-science, or pseudoscience, was that the question is whether it's falsifiable or not. Kuhn rejected that. Kuhn rejected that. He thought that falsifiability is neither necessary nor sufficient for a theory being scientific. And also, he rejected the view that scientists try to falsify their theory. Not that, I mean, scientists do the opposite. I mean, they don't try to falsify, they believe in their theories, they work with the theories, I mean, and falsification is something that is very rare and only in a state of crisis. So most of the time, most of the life of the science and its theories, there is no attempt to falsify. Also, he thought that, first of all, he argued that a lot of theoretical parts of claims, the theoretical parts of science, are not falsifiable in principle. So take, for instance, I mean, we talked about gravitational force. Remember when we talked about Popper and falsification? So gravitational force is something that you cannot falsify. For instance, according to general theory of relativity, there is no gravitational force. Things behave the way they behave because space is not straight everywhere. Wherever things, I mean, are very massive, space is curved, and it takes, you know, for things, I mean, more time or less time to go from one place to another. So they have a different trajectory because the shape of space, but there is no gravitational force. Now, general theory of relativity accounts for the same phenomena as Newtonian physics, Newtonian gravitational theory. So surely, I mean, the gravitational force is not something that we can falsify. It's a matter of theory. We have a theoretical hypothesis Newton had that there is a gravitational force, and now we change the hypothesis. So Kuhn argued that a lot of science is like that. It's not something that you can actually falsify. It's something that you may connect to other theories and other hypotheses and other facts, and maybe only then you can predict something that is observable and falsifiable with induction. So a lot of science is not falsifiable. And usually, I mean, also, and usually there is no set of experiment that can tell you like copper, I mean, argue that it's falsified or not. The second reason why falsification is not a criterion for being scientific or not is that the fact that, I mean, a theory or something is falsifiable doesn't make it scientific yet. You can have, I mean, things that are falsifiable, but they are not scientific. So it's neither necessary nor sufficient to be scientific. According to Kuhn, what makes a theory scientific is that it's guided by paradigms. There are certain what is a paradigm is not easy to say, and Kuhn actually spent most part of the book, I mean, in order to explain. And some people complain that there are so many meanings, there's maybe 22 different meanings for what is paradigm. But the idea of paradigm is that there are some kind of conceptions that the scientists work under. So, for instance, in Newtonian physics, a conception is a conception of a force. Is a mechanical philosophy, how things influence each other. For instance, the notion of time and space is that time is absolute. So that's part of the paradigm of thinking about time and space. While, for instance, in special relativity, time is relative. So it's a different conception and different paradigm of time. So in general, the science has a paradigm. For instance, the quantum mechanics is a different paradigm than classical physics. Quantum mechanics, things are not continuous. For instance, there are changes in quantum. Quantum mechanics is indeterministic theory. The past doesn't determine the future, while classical physics is deterministic. So all these are paradigms about thinking about nature. Some of the paradigms are metaphysics, so metaphysical. So they are paradigms about the nature of time, the nature of space, the nature of causality, whether the world is deterministic or not, and so on. So these are paradigms, and we talked about some of them when we talked about the nature of space and time, for instance. We talk about paradigms of explanation, for instance. For Newton and Leibniz, the paradigm of explanation implies that one has to talk about God. God is very important for explanation. While in modern science, the paradigm is different. Even if one is religious, it's not legitimate to talk about God in scientific explanation. You cannot send a paper to a top physics journal and say, well, God explained A and B, and it doesn't matter whether you are religious or not. I mean, the best, I mean, there will be a kind of polite reply that it's not the right venue to send the paper. I mean, you have to send to theological journal or something like that. And it could be even less polite to say that. So the issue is that there are different metaphysical paradigms, and what makes a theory scientific, that it's a part of a paradigm. So a community that works under a paradigm, certain paradigm, is a scientific community. Okay? So when there is no ruling paradigm, there is no science, even if people do something that looks like science. So for instance, psychology at some point at early stages was not really a science because there wasn't one paradigm that ruling, I mean, the science. There were a lot of different paradigms, there was disagreement and so on, so it was a stage of pre-science. Science is a stage in which one paradigm takes over, and most of the scientists work under this paradigm, educated according to this paradigm, and so on. So the paradigm now in physics, for instance, is that is governed by quantum mechanics, by general theory of relativity, and some other theories. Okay. Second, the paradigm determines the methodology of investigation. So, for instance, part of the paradigm nowadays is that you have to do experiments. That experiments are very important. So it's part of the paradigm that to learn about nature is not just reading books like it was before the Renaissance. More acceptable, or like a lot of books. You have to go and actually do experiments and so on. And also the methodology, the paradigm also determines what kind of experiments and how to evaluate experiments, how to confirm theories and so on. There is different, the paradigm also determines the technique of how to do experiments. The paradigm also tells the scientists how to deal with anomalies and things that disagree with the theory. For instance, the paradigm can tell that, for instance, during Newton's theory, there were always, facts that seem to be inconsistent with the theory. But according to Kuhn, scientists don't falsify the theory. Scientists just say, well, this is a bit of a problem, kind of puzzle, we will solve it in the future. They just put it aside. So another reason why falsifiability is not, why it's not so important, that scientists, even when they know that there are facts that contradict the theories, we say, they don't call it a contradiction, they call it a puzzle. Something that they are optimistic that they can solve in the future, but for the time being, they just put aside. So, if you tell the scientist, there is this problem, say, yeah, I know this, but it's not the most important now. We focus on that. We will deal with it in good time. And also the paradigm tells scientists how to choose, which problem to choose to work on and which to put aside. So for instance, the paradigm can tell people, this is a problem, but put it aside. If you try to work on this problem, people will not publish your papers, for instance. You will be marginalized or something like that. So there is, the paradigm determines this. Paradigm also, it's not mentioned here, it's very important, paradigm determines also the education. So the education at the university is according to paradigms. There are ways to educate students, and whoever doesn't walk in line with this usually is marginalized. Become either kind of quirky scientist or non-scientist. It's the way you think, it's kind of conception and way of doing things that guide the scientist. So paradigm could be understood as conception, could be understood as certain methodologies, they understood as certain assumption about the science and so on. So certain way of educating and so on. When you say paradigmatic case, you take, so for instance, part of the education is to take paradigmatic cases in each science and teach them. Okay? And that's in order to actually develop the intuition and the way of thinking of the students so that they will become scientists who follow that way.
It seems that paradigm is the synonym for epistemology or logical beliefs.
Also, but it's more than that. It's because there can be a lot of paradigms that are very difficult to articulate. It's just a way of doing things. If you are not in the laboratory and you haven't been socialized, you don't have the same paradigm. So the experimentalist would say, no, you don't do things in that way. Then you ask them why, they might not be able to explain, but that's the way people do things. And that's part of the paradigm. So for Kuhn, theories that are not guided by paradigms are not scientific. They can look like science, but they are not science. So, as an exercise, is evolution theory a scientific theory? What would Popper say about it? Yeah, Popper said at some point actually that evolution theory is not scientific because it's something that we cannot actually post. The evolutionary people will always come with explanation why things seem to be different from what they are. But for Kuhn, evolution could be a certain paradigm for how to look at nature and how to understand, I mean, the history of our planet, related to biological. So it could be, even if it's not falsified, it could be part of science, and it is part of science. I mean, that's what many people think. I mean, there is evolutionary biology, and it could be department, what is part of the department program. And according to Kuhn, it's fine, because, I mean, this means that there is a certain paradigm in looking at nature. And this paradigm, for instance, is competing with the creationism paradigm. That there is a certain evolution, I mean, of things that they evolve, and they evolve by chance. We don't have our limbs just because, I mean, there was a design. They just that by chance there was some development, and they happened to be efficient in terms of dealing with our environments, and they were just repeated. And became more and more. And the same could be with psychoanalysis, or is astrology scientific theory? Not nowadays, but in the Renaissance it would have been. Because back then it was part of the ruling paradigm, and now it's not. Now it's for the newspaper, or people who are considered, I mean, astrologists are not considered scientists nowadays, because they are not in line with the paradigm. But as we saw in the Renaissance, astrology was very, very respectable. So that also tells you that paradigm could change. And when paradigm change, the science changes. If you keep supporting the old paradigm, you become non-scientist, or you become, like marginalized. You become kind of strange. I mean, your paper will not be published anymore, you won't be invited to conferences, or if you're invited, you're marginalized, and so on. So the first thing is that the distinction between science and no science is very different for Kuhn than for Popper and the positivists. It's not based on empirical consideration, mainly. It's based on a certain conception of how to do science and certain assumption in the science itself. So if the paradigm has a certain metaphysical assumption about nature, a certain methodological assumption about how to do science, certain ideas about how to educate people, for instance, exercises and so on. Part of the paradigm is not to talk about philosophy, for instance. So discussion of philosophy, I mean, kind of not in class. I mean, it's here. If you want to get elected and talk about it, don't take too many, too much influence and so on. But that's part of the paradigm. I'm kind of exaggerating. It's not everybody like that, but it's not by chance. I mean, that philosophy of science is not taught in the sciences. It wasn't like that always. We saw, I mean, in the Renaissance and other. We saw that to be, I mean, a scientist was to be a natural philosopher, a physicist. So it was a very different paradigm. And the paradigm has changed. Once the modern paradigm, natural philosopher is not a physicist. Maybe a philosopher of physics, but not a physicist. So, and there is no, while the positivists made a sharp distinction between science and metaphysics, for Kuhn there is no sharp distinction. Part of metaphysics is, I mean, metaphysics is part of science. Certain kind of metaphysics is part of science. And scientists, according to Kuhn, always assume metaphysical assumption. So even if people say, we don't deal with metaphysics, implicitly they have a lot of assumption about metaphysics. An example of metaphysical paradigms about causation, for instance, in the 17th and 18th century, the type of causation was mechanical. To understand something influence something else, they have to interact. According to quantum mechanics, I mean, it's not the paradigm anymore. Actually, in quantum mechanics, things are not well located in space, so they cannot even interact in the same way. So the concept of causation changed a lot. I mean, and the concept of explanation and so on.